Okay, so lesson 5 is talking about designing inheritance hierarchies. So the goal of this is to understand how to build useful inheritance hierarchies that support our general goals around building useful productive class libraries. And part of that, we're going to dive into this whole interface versus base class discussion. So I just want to start this section off with a little bit of a story here. I was talking to actually in one of these classes, Anders Halsberg was presenting, and somebody asked him what the biggest problem with API design is. He's been around for a long time. He's seen it in lots of different environments, and certainly seen it over Microsoft for the last couple of years on the .NET framework. And he essentially tells this story of the biggest kind of repeated problem, and that's that what you do is you get a new developer, a new program manager, kind of brand new to an area or brand new to Microsoft, and you ask them to design the widget feature. And they're going to design just the most phenomenal widget feature that you've ever seen. They're totally going for the 4 or 5 widget feature kind of work. And one of the things they want to do is make it super feature rich. They go and do tons of competitive analysis, and they get every feature everybody else remotely related to widgets has, and then they have this really complex extensibility story to widgets, such that any partner can plug in and do absolutely anything with widgets. And so that's underway. That dev work is going on. It's about halfway done. So you're about halfway done, and then the reality of shipping sets in, and you get one of those mails from Jack Mayo or from whoever the release guy is in Office that says, essentially, if it's not done, it's cut, right? I mean, at some point, the realities of shipping software come in, and we have to decide about these features and which ones are actually going to survive and which ones have to get cut. And at those times, we don't usually take a long, deep reflect and think about how could we redesign this thing to make it simpler so it's scoped to fit. What we do at that time and say, wow, what has a long bug trail? You know, what can we cut off and make us get to market faster? And so what happens is we end up shipping this thing with the wire still hanging out of the box, with the design that's not quite complete. We kind of lopped off some things off the end. So it not only did it not meet fully meet the requirements that we laid out, but even worse, in vNext, when we actually know how to make this thing extensible, we know what we want to do to it, we have concrete partner requirements that we're working with. We know what needs to happen in the extensibility scenario. We're actually blocked from doing it because the wires are still hanging out of the box. We've already kind of half done it one way, and that kind of affects the degrees of freedom that we can have in the future. So the moral of this story is that you should not over-design the feature. Design the absolute minimum thing that we can do now for the requirements that we have now, and then that leaves you room in the future to add the more extensibility that's needed. So it's kind of interesting that I'm starting a section on design inheritance hierarchies and extensibility with a story about not doing too much extensibility. But I think it's true, and I think if you take a long-term view of the platform, then you'll recognize that I have it on very good authority that there will be a version of Windows after Longhorn. We absolutely will do another version. So if it doesn't get in Longhorn, it doesn't mean it'll never happen. So you can do the minimum now and then add more to it in the future. So okay, so with that introduction, let me talk a little bit about abstract classes and base classes. Base classes serve as the generic term for a class that serves as a root in an inheritance hierarchy. A base class is a class that you inherit, that other types inherit from. And abstract classes are a special kind of base class that have members that must be implemented, that are required to be implemented by people that subclass them. So my general rule, we mentioned this when we talked about exceptions, but my general rule is to prefer broad, shallow hierarchies. And the reason for that kind of back-of-the-napkin rule is that as inheritance hierarchies get deeper and more complicated, the contracts between the types get harder to maintain. So it's essentially what I'm saying. So it's easier to define inheritance hierarchies and maintain inheritance hierarchies that are not as rich and complex. So you should think about the base classes that you have in the system and consider what their crisp role in the world is. Like, what is it you really want from that type? Is what you really want from that type a utility type that can be used, or do you want it to be a base in a hierarchy? And I've seen some problem designs where we kind of want it to be both. We want it to be both this base thing and this kind of common used thing, and those are oftentimes smell fishy. One of the ones that may be a little bit controversial is I'm not super excited about what we did with system exception. It was one of my types, but in retrospect, exception, I wish we had just said, you know what, exception's goal in the world is to be the root of the hierarchy for exceptions. That's its only mission in life. It's not meant to be some generic exception you can throw when you don't have anything better. So in that case, I would have just not had the public constructors, had all those constructors be protected, because they're meant for subclasses to access. And then you wouldn't be able to say, throw new exception, I'll fill in the message later. And we've actually shipped a few of those, so I think that would have been a net positive to the platform. Okay, so that's types. And then at the method level, methods can be virtual, abstract, or non-virtual. So virtual members are points of specialization in your code. There are methods where you're saying, you know, here's a default implementation, but people subclassing me, you are free to just take my implementation and chuck it out the door and provide one of your own. I don't have any particular love affair or implementation entanglement with my own implementation. As long as you meet the contract, you can use it. Abstract is the same kind of thing, except for an abstract member says you have to provide an implementation. I'm not giving you anything to start with. There's kind of no seed code I can give you. You have to do the whole thing. And then non-virtual members are members you go, you know, this is my implementation. I would like to be sure when I call this, I always get my implementation. I have some dependency on this code being called when I call this method. So mark that thing non-virtual. And it's interesting to note that non-virtual is the default in C# and in the CLR. And that's because we feel like that should be your default when you're designing the frameworks. Again, if I could do it, if we had infinite time, I would have the platform be infinitely extensible or fully extensible. But we don't have it's not worth the cost-benefit trade-off of making every type infinitely extensible. So we have to be careful about where we put the extensibility hooks and make sure they're designed in. So by default, you make it non-virtual, and then as you understand what your extensibility requirements are, you can make those things virtual. It's not a breaking change to go from non-virtual to virtual, but it is a breaking change to go from virtual to non-virtual. Okay, so I think that virtual members are super powerful in the platform. But they're also very dangerous, and I want to kind of illustrate a little bit of why that is. So let me just give you this example here, and that is, so I have this public class called the base, and it inherits from system.object, as all methods do, all types do, and it overrides object's toString method. So what does object's toString method do? Anybody remember what object's toString does by default if you don't override it? Yeah, it prints the type name. Somebody said that. It prints the type name. So in this case, it would print the base, because that's the type name. So what I'm doing here is I'm overriding it. I'm saying, look, thank you very much, object, for that implementation. I'm going to completely replace it with my own implementation, and I'm going to return hello from base. And then I have another class called derived that inherits from the base, and it overrides toString again. And this time it says hello from derived. Okay, so that's the scenario. So now what gets printed out? So I create a new instance of derived, and I call the derived.toString. What gets printed out? Hello from derived. Okay, so now I cast that derived to the base, and I call the base.toString. What do I get? Hello from derived or hello from the base? Okay, so there's a little difference of opinion. Okay, let's keep going. So object. So now I cast it to object, and I call object.toString. You get hello from derived. Hello from derived. Hello from the base. The instance. What would be the name of the type? What do I get? The runtime type. Yeah, the runtime type. Right. That's what objects.toString would do. So this is actually a guy on the team was actually playing around with this one time, almost this exact same example. He came, this is totally a bug. I've absolutely got a bug, Brad. Let me show you this. And it was not a bug. It's the way virtual methods work. They all print hello from derived. They all print hello from derived because the runtime type of all those things is derived type. And so the most derived guy gets to decide what it is, no matter what the static type of it is. So that means if you have an API that's typed to take your thing, let's say your type is called the base, and you're expecting your members to do a certain thing, well, if they're virtual, they may or may not do those things. You may or may not, that code may or may not be called, depending on what the people that subclass you do. So I call that both the power and the danger. It's the power because it was amazing. I was at the PDC and I was doing a presentation on our streaming system. Where I mentioned we have this kind of powerful extensible streaming mechanism, and I showed how I could take a stream and I could encrypt it or use a network stream or a file stream. I had this class that worked over any type of stream. And then I met at the conference a guy that did a compression stream of V1. I had never met him before, never talked to him, and all I did is plug his code in, and it just worked. And now my demo did compression as well. And that was it was because we had the right things virtual on stream that I didn't have to know anything about his implementation to be able to use it in my generic framework. So that worked great. That was the power. But then it's also the danger. It's the danger because people replacing your implementations of methods could be doing anything they want to do. And as you're calling those virtual members, you need to be aware of that. Okay, so along those lines, so as I mentioned, when you override, technically anything could happen, but what should happen? What should you, as framework authors, do when you override each other's types? I mean, essentially, some of you are defining some types, and some of the rest of you are going to override, subclass from those types and derive from them. So what should you do, and what should we be telling our customers they should do, even though they could do anything? Well, the first thing you should do is follow the well-defined contract specified in the base class. So the base class defining a virtual member should have taken the time to have written a well-defined contract for what overrides are supposed to do. In terms of the order in which they're to be called, whether the base is supposed to be called or not, the kinds of operations, the kinds of exceptions that can be thrown, that sort of thing. Your contract should define all of that. And if you have to override a base class that you look up in MSDN and you see no contract to be found, that is absolutely a bug. You should totally file that bug, get up with the person who wrote that class, and get that fixed. And if you're defining a class, you should absolutely define the contract for it. You should also, as you're doing this, you should also make sure that you don't require any specialized knowledge. If you in my example, I wrote code that just consumes streams, something type system.stream, and if in my code anywhere I had to write, if S is really a network stream, then do this, otherwise do this, then that indicates that there's some kind of problem with the code. You shouldn't have to have specialized knowledge. Yeah, and I already mentioned you may want to call the base. Yeah, so generally in extensibility scenarios, you should have whenever you have virtual members, you should point to a concrete scenario you have in mind. I should be able to pick up your class and say, why is that member virtual? And you should say, because the foo scenario requires it. Here's the implementation of the foo scenario right here. So I literally mean any class that has virtual members on it, somebody, it might not be the developer, it might be the test team or the UE guys or the PM, somebody should actually write a subclass of every class that introduces a virtual member and shows how it's used. It actually demonstrates that it's a useful thing to have. That's a useful thing to have, and that no more is required. Oftentimes I feel like, well, I kind of felt like making that virtual. It seemed like virtual was a good idea. They were having a sale on virtual keywords. There's some bizarre reasons, and you end up making something virtual that shouldn't have been, which is kind of bad from a future standpoint. And then you also end up blocking a scenario if you don't make something virtual that should be. So you should have some concrete scenario in mind. Now, that might mean you miss some, because if your concrete scenario doesn't include some other scenario, then you might miss it. That's true, but at least you've got one concrete scenario that works, and in V2 you can add concrete scenario 2 that works as well. Okay, so abstract members, any properties, methods, events, all can be abstract. You should, generally speaking, you should only use abstract members where you can do no other implementation. As a general rule, I would prefer to have virtual members because you're making it a little bit easier for the guy subclassing you to get it right. With abstract members, I'm completely left on my own to kind of make up all the implementation. It is a little bit more work, but actually what really bothers me about it is there's just more chances of introducing bugs. If you do most of the work in a virtual member and they have to customize a little bit and then call base.blah, then it's much more likely the system to actually hang together. So I already mean the default to making things non-virtual. Yep, I think I mentioned all that. Okay, so one place that we go is this whole interface versus base class thing. When should I model something as an interface? When should I use a base class? And they're certainly all really, I mean, both of them are certainly playing an important role in a well-designed framework. But I think that we're trying to learn something from the COM days. One thing I noticed about COM is COM was essentially an interface-based model, right? Everything was IFU, and you implemented these interfaces, and they were fairly well defined. I mean, you can pick on some of them that don't have good docs, but they were fairly well defined. But yet, if I wrote a component and it works great in VB, I write a COM component, it works great in VB. What are the chances that it works well in Word? But they're both containers, right? They both implement the right interfaces to be containers. So if I write one that works in VB, shouldn't it work in Word? Well, the truth is, 90+% of the time, it wouldn't work. Anything but the most trivial one wouldn't work. You'd have to, oh yeah, Word actually doesn't implement these properties. It implements this thing this other way. And then you go and take that thing and try and host it in IE. Will it work? Well, no. Okay, Trident does things a little bit different. I have to do this and that. And I think that's because there was a lot of these shared operations that we ask everybody writing an ActiveX container or a COM container to go implement. And it was just shared glue code. If we had one team that wrote all of it, and then everybody else was able to use it and customize it to their needs, we would have had a higher chance of that substitutability actually working. And base classes give us that ability. With a base class, you can define the base information, and then everybody else can subclass and customize what they need to do. In addition, there's this kind of debates around the versioning of interfaces versus base classes. And kind of at a high level, with base classes, you can add new members to a base class. You can say, oh, I forgot about something, or new business requirements force me to add a new thing to this base class. You can do that. But with interfaces, you can't add new members. That contract is locked. You have to create a new interface member. So we'll talk about that here in a bit. But one thing is kind of typical, what I call typical Microsoft thinking. When Microsoft is faced with a hard problem, what do? Let's offer the user an option. Anything that's difficult for us to design, let's give the user another option. Look at the number of options in the VS IDE, for example. I mean, it's just ridiculous, tab after tab of options. So I think that sometimes that's good, but a lot of times it represents a failure of us to decide. So sometimes we have this component I-component problem, and we just couldn't decide what we really wanted to do there. And we actually, so the vast majority of components in the system derive directly from component. In fact, I think everyone in the system derives directly from component. But some test cases obviously had to test the I-component case because we were giving that to customers and they could use that. And we would just always be failing those test cases. They were only run periodically, and every time we'd fail because the system, everything else derived from component, so the system, people always made the assumption that only those things in component were required. So we had to kind of up the test case on I-component to make it work. And it netted in little advantage. It didn't actually save us anything in the debate there. Okay, and we'll talk about these other points a little bit. So aggregation. So one thing about interfaces, lots of times with this whole debate, people ask me about, well, I have multiple, somebody might want to derive from this other class. I don't know what people might want to do. Am I going to be their only base class? So is this class going to be the only base class? It's kind of the single root problem. We have a single inheritance model in the framework. And it's, I guess my point on this aggregation thing is it's not the end of the world to have a single root. The aggregation pattern's fairly simple one for customers to do. They just pick one to derive from and another one to have kind of a property that returns something of that type. It's generally speaking not the end of the world to burn the base class slot there. Okay, so let's drill in a little bit to how interfaces version, just to kind of bring it home. If I had iStream in V1 and it only had reading, we thought we could probably get by with just reading. We don't need writing. And in V2, I decide, okay, so start with only reading. And then I implement FileStream in a different assembly. It implements iStream and it only does reading. So that all works great. And then in V2, we go, hey, wow, there's this newfangled writing thing that I need to have as well. So you add write, and now FileStream won't load. FileStream, the runtime goes, whoa, FileStream, you don't implement the write method from iStream. See, so now FileStream has to be updated synchronously with iStream to add that. And it's interesting, one interesting kind of anecdote around this, the problem actually got so bad in the Java world, they actually took that check out of the loader. And so at least in some of the VMs, a type that doesn't implement all the members will actually load just fine. And if you cast it to the interface and call those members, then it'll blow up. So, and they did that for exactly this versioning reason. So let's look about how that scenario would play out if we had base classes. If stream had been a base class and we added read in version 1, same thing, file stream. Version 2, I can add write. Now, I have to do some kind of default operation in my write, which means I probably have to throw some non-implemented exception. But at least FileStream can keep working, and independently, when FileStream gets around to it, it can be updated to implement the new functionality from write. Does that make sense? Okay, so all that said, though, I do think interfaces are very useful. So where are they useful? The more focused the scenario for interfaces, the better. An interface with like 80 members on it, I worry about whether those contracts can be maintained. It seems like a very complicated contract. It'd be better to have smaller, more focused interfaces. I think iComparable is a great example of it. I-formatable, things like that that are additive in nature that you want to kind of glue on to a type. Yeah, it'll do this and this and this and this. So these are other functionalities that it could have. I want to spend a little bit of time talking about explicit method implementation because I think it's one of the CLR features that's not very well understood. What it allows you to do is implement an interface member privately. Now, you can't implement the interface itself privately. That's not supported. You can't like kind of implement an interface and not tell anybody that interface is actually implemented. We don't support that. But what we do is make it such that you can satisfy the construct of that interface with private methods on your class. But it's not a security boundary because all I have to do is cast your type to the interface type, and then I can call those private implementations. So it's not a security issue. It's more of a cleanliness issue in the public surface area. And so, for example, I don't know if you've seen that we have this I-convertible interface that has the 16 or 18 2XXX methods, 2 int, 2 double, and we want all the base data types to implement them. But then we thought, God, do we really want in32 to have like 18, 19 methods on it of this kind, when what we really want to do is encourage people to use the convert class because that's one-stop shopping for that stuff. And so we decided we would encourage people to use the convert class by privately implementing or explicitly implementing the I-convertible members on int32. Yeah, so that's essentially that example there. So you see how it's explicitly implemented? It's implemented with I-convertible .toString. And the no public keyword means that thing is internal or private. So it's not available on just an instance of I. So I.toInt32 wouldn't compile. But if I cast I to an I-convertible, I can call toInt32. The other place that's interesting, and to be honest with you, I haven't seen this one actually play out yet, but I think it's because the framework's not old enough yet. We don't have enough code in the framework yet. But interfaces have a little bit of a problem where if I have a class that implements two different interfaces that have the same name, that have methods of the same name and same signature, then they would be satisfied by the same method, but they could do wildly different things. So for example, say I have one interface that has a draw in it, meaning draw a picture, and another that has an interface that has draw in it, meaning draw a gun. I probably have wildly different implementations of those two members, right? So I want to have a way to actually differentiate those two things. And so this is just an example of that. So I have iGraphics and iBandit, and then I have this bandit class that implements both of those. And I'm able to provide distinct implementations of these two things because I have this explicit implementation support. Okay. So choosing the right route. Let's try working through these together as well. So define a type that describes the contract for comparing this instance to another. What's a good answer? What's a good way to do this? Anyone? I-comparable? Yeah. Okay, fine. You're picking on my creativity. But a couple of keys here is it's a contract. It's a simple contract. You should use interfaces for that. That's a good call there. Define a type that describes a contract for all kinds of employees in a database. Like say I have a database and it models contingent staff, full-time employees, executives, blah, blah, blah. Well, okay, why a base class?
Because there are a lot of methods which you can have the default implementation for, and on top of that you can add on.
Yes, yeah, right. There's a bunch of methods that have a default implementation, and then you can customize it. So I can have a fire method in the base employee class that cleans out the record and kills their email account, and then I can special case it when it's an executive to make sure we get rid of their stock options or whatever. So yeah, totally. Any other thoughts on that one? Okay, so in summary here, we talked about being very careful about using virtual members, about how to choose base classes versus interfaces, and some bits about explicit implementation. So questions? Yeah.
I have a question about the base class interface debate.
Okay.
My question is, I'm trying to summarize the build-up.
Okay.
Base class is used if there is some default implementation that will be carried through of inheritance. Interfaces, like if I will have a base class that all the functions in the base class are abstract, then it would have much better if I use an interface.
So it's close. So his question is, so I have a base class, so I should use, let's see if I can remember here. I should use an interface. It would be better to use an interface if I had abstract class where every member was abstract. Would it be better to use an interface there or not? And I think that it depends. I could totally see having an abstract class, every member is abstract. If you think, you know, this is actually somewhat complicated thing, I may want to add some new things in the future to this. So the thing is, if I have an abstract class with all members abstract or an interface, in V1, they have the same problems associated with them in terms of there's no default implementation that you could do. But in V2, in the abstract class case, I can add new members to that.
But if these new members won't be abstract,
it would have to be virtual. And in this case, you can use a new optional pattern that we just published today, actually, where let's say you're adding the ability to write. You might add a can write method that returns false, and then a write method that throws a not implemented exception. So unfortunately, it's not as simple a debate as can I provide default implementation or not. It's more about how you want the class to be used. Yeah, in the back there.
The discussion would be base class versus an interface. Is there any performance consideration we should be careful about while having base classes? Because my understanding is when you have a subclass and say instantiate it, you're going to actually create an object of this subclass as well as you're going to create another object of the base class, which is not directly accessible, but in the essence, it's actually two different objects which are being handled in them.
Yeah.
Overall, like having more object applications as opposed to interface when you don't really need one for the.
Yeah. So the question is about when I have a base. If I have a base class and I derive from it, then when I create an instance of the derived class, do I also create instances of the base and the derived? And the short answer is no. You don't actually create kind of separate instances of it, but what you do create is a single object that has vtable slots for the base, for the derived and the base. And if you have any instance data in the derived, then it'll be allocated. Any instance data in the base, it'll be allocated. So you have kind of one thing that's the sum, and then kind of compare that with interfaces. With interfaces, well, you can't have any state at all, so that maybe is a little bit of savings, but you could not have state in the base class case as well. And then interfaces actually has a very similar kind of type layout in the vtable. You'll have a vtable for the interface members as well. So I think that in terms of performance, there is there's nothing noteworthy in the performance case to warrant doing interfaces over base classes.
So in what scenario is it completely foolproof to say, yes, I'm going to do interfaces?
Is it completely foolproof to use interfaces? Well, I guess I hesitate to claim I know an absolute black and white thing. I mean, okay, so completely foolproof if you are interoping with COM interop needs to be exposed as an interface. If you don't provide one, we provide a class interface for you. But, I mean, I don't think that really gets at the heart of your question. I think that, unfortunately, the reason why this debate is so hard is we haven't been able to be, I would argue, we can't be 100% crisp on, yes, always interfaces here and always base classes here.
Base class implementation doesn't do anything. What use it
that you can expand it later.
Right, so this is a similar question. So the base class, he's saying, look, if I have a base class and I don't have any default implementation, should I just use an interface? And I would argue, well, maybe, but you could still be better off to use a base class because you can add new members to a base class later, whereas you can't with an interface. I guess, I mean, if somebody came to you with a base class with a bunch of members and they were all abstract, I would really question, though, are you sure there's no default you can do? There's no, one cannot be implemented in terms of another, for example. And oftentimes that's possible. You have some core thing that is abstract, but the other things are implemented in terms of it. Yeah. That's right. That's right. The big win with interfaces is it solves the multiple base problem, right? And a class can implement multiple interfaces. But that's true. But we do have the aggregation pattern where if I have two roots I want to implement from, I inherit from the primary one and expose a property of the type of the secondary one. So but that said, if you are absolutely in a case where you have to have multiple roots, then it's a fine thing to do. Other comments or questions about the whole section here? We have a couple of minutes. Yeah.
Kind of a general overhead question.
Sure.
And it comes up a lot. You have lots of collections of objects, and let's say you have a collection of things that you know are strings. Would it be more efficient to call the virtual toString function off the object, or to cast it to a string? Like they both have to look up and check the type and stuff, right?
So you're saying, would it be better to call?
Lower overhead.
Would it be better to call object.toString or
cast the object to a string if you know it's a string?
Or so you better call. So you know you're dealing with a string. That's the runtime type. Would it be better to treat it as the runtime type or treat it as the base type? I would be shocked if there were any difference at all in those, because I mean, if all the members are available to you, there's not going to be any difference. If you have to end up calling one late bound, for example, if you use reflection or VB's late binding support to call it, okay, yeah, that's going to be a lot more expensive. But like the example that I showed earlier in the slide, there's no performance difference that I'm aware of for those. Okay, any other questions? Okay, yeah. Yeah, so the question is, if I override a non-virtual function. Yeah, if you override a non-virtual function, then you'll get a compile error, and the compile error will ask you to put the new keyword in front of that member, and if you do that, it actually generates a new slot in the V table that does not override. It hides the one from the base class. I don't know if does that make any sense? But the net of it is, if you mark your member as non-virtual and you are calling through an instance of your base class, you will always get that implementation, even if somebody below you provides another member of the same name. Other questions or comments? Yeah. Okay. Where, do I have a clear example where inheriting from two interfaces is bad or good? No, wait a second. I just want to make sure I'm clear. I don't, it's fine. Like, N32 implements two interfaces. It implements I convertible and I formatable. And I comparable, right? I mean, it implements a lot. So implementing multiple interfaces is not a problem. What I think needs some more thought. The thing that I'm kind of exhorting you to do is don't give up on base classes just because you say, well, my user might need to inherit from somebody else. That's all. That's my only thing. It's fine. It is completely fine for your class to implement multiple interfaces. In fact, I would argue desirable to kind of add on functionality like that. Any other questions, comments?